So, this next module is called Solutions, Innovations, and Case Studies. And it's a compilation of lessons learned from our really amazing ecosystem that's comprised of both the experts and the fearless novices who have been working in the realm of indoor air quality for quite some time and building science specialists from a variety of countries. And the purpose of this module is to really share and hopefully inspire all of you, the future accredited professionals, and not to just simply dole out some answers, because we don't have all the answers, admittedly, and there is no one-size-fits-all sort of silver bullet when it comes to the complexity of indoor air quality. But the hope is that you can benefit from the collective knowledge that we've gathered to date and use it in your own way as an AP to assist clients and advise on some best practices. So this section is really dedicated to the many experts and professionals that have contributed their work, their insights, and their time for the greater good of our industry. And I hope that all of you will continue your experiences as well and bring them back to us, because we have only really begun to scratch the surface. There's a whole lot more to be learned in order to get us to the goals that we need to be at. So indoor air quality solutions. To kick this off, I want to sort of talk about really the most basic concept of control here, which is source control for indoor air quality purposes. This is the most basic and obvious place to start. If you want to have better indoor air quality, don't use products and materials that pollute the indoor air in the first place. So, source control. Nip the problem in the bud, if you will. And if you recall in our earlier modules, when I was discussing the target pollutants, many of the culprits that contribute to poor indoor air quality derive from the construction products, building materials, interior finishes, things that you install in the space. So the easiest way to prevent indoor air quality issues is to just eliminate the inferior products and materials in the first place. Now, that's easier said than done. To successfully do this, it takes significant effort and due diligence. Every product, every finish, every material has to be researched and reviewed and cross-checked against a prescribed set of criteria. And if you've done the material vetting for a project before, you know how difficult this can be, gathering complete disclosure of chemical ingredients, all that information, as well as information on VOCs and off-gassing. And further, it's ideal if you can get this information verified by a third party. And this is just not an easy ask. It's demanding and time consuming. So much so that because materials are such a critical and complex piece of the indoor air quality puzzle, it requires a much deeper conversation. And we actually have developed a separate reset module dedicated solely to this topic, the reset materials module. So please take heart. We will have another webinar and training that you can look forward to that will review all of these issues in the coming months and assist you in that effort. But in the meantime, there are resources available to help with this heavy lift of materials research. And Giga runs one of the largest and most dynamic material data hubs in the world called Origin. So this is a free resource, open for anyone who wants to use it, and it's internationally driven, displaying both resources, materials, finishes, and contacts for suppliers and manufacturers from all over the world. And some of you might be familiar with Mindful Materials. That is powered by the Origin Data Hub. So the Mindful Materials library is drawing directly from the resources that are housed within Origin. So if you need materials, this is really a great place to start. You are welcome to go to the Origin website directly, which is there, or to Mindful Materials. Okay, so let's come back to mechanical systems and how their design and operation can help solve some of our pressing indoor air quality issues. In the past, the rule of thumb is all about solving problems with this knee-jerk reaction, which is get rid of your high concentrations of undesirable pollutants and gases by introducing more outside air. or fresh air. I'm using air quotes there because fresh air is not necessarily outside air. Outside air is not necessarily fresh air. So making the distinction there, you may have heard this sort of catchy phrase of dilution is the solution to pollution. Well, sometimes that approach works, but there are significant consequences to this as well. The first being an increased amount of particulate matter if your building is located in a place where the outdoor air is polluted. And anymore, it's becoming increasingly difficult to rely on this strategy. Most of us do not have the luxury of just being able to open the windows or outside dampers to let outside air in. So in many places in the world, this option only results in introducing higher levels of particulate matter into the space. And then additionally, there's the issue of increased energy that is needed in order to condition that air for both humidity and temperature. So although more outdoor air may help decrease CO2 and VOC levels, or at least hopefully it will, the trade-off is increased particulate matter and energy use. So the second line of defense is to just add more filtration, or any filtration on top of your outdoor air that you're bringing in. And this strategy requires a lot of extra energy. It takes so much more effort to force that air through the perforations, the tiny spaces in the filter media, and that added resistance equals added energy that you need. So like as an analogy, I suppose you could think, for example, how much more difficult it is for someone to breathe with a surgical mask on or a respirator. Well, building mechanical systems are not too dissimilar. And then further, the approach of adding extra filtration not only increases the building's energy requirements again, but it can contribute to the very problem of pollution that we're trying to solve in the first place. So then there's a fairly new innovation that's pretty exciting, which is the energy recovery ventilation, or ERV systems, that are getting more traction today. And we're seeing a lot of them installed in addition to filtration. Now, with this improved approach, we can potentially reduce the energy demand, or at least get it down to some baseline levels, and aim to have filtration medium that can actually deal with the particulate, VOCs, that type of thing. But we're only reaching the energy levels that we started from. We still aren't getting down to the reduced levels that we need to reduce our carbon footprint and prevent further pollution and global warming. And of course, there's still the financial impacts associated with the energy that you're using. So what's really exciting about some of the case studies and the experimental projects that we've seen over the last several years, and that we're going to talk about a little bit in this module, delves into this approach that you're seeing on the screen, which is the introduction of active green walls, or what some enthusiasts have coined living machines. And together, all of these technologies, and we'll see through a couple of pilots, are helping to solve some of these really complex indoor air quality issues across all parameters. So we're going to go into those a little bit further. But before we do that, I think it is worth talking a little bit about ERV. So I just mentioned it, ERV. Again, it stands for Energy Recovery Ventilation, or ventilator, depending on what tense and what circumstance you're talking about. But ERV is the energy recovery process of exchanging the energy contained in air that is normally exhausted, and instead you're using it, you're treating it, preconditioning the incoming outdoor ventilation air. So basically, it's a box where stale indoor air bypasses fresh outdoor air, and they don't mix. There's no mixing. But in the process, it does this energy exchange, or recovery, hence the name, so that you don't have to be conditioning the air from its most extreme states every time. So the benefit of using ERV is that it's an effective means of reducing energy costs, obviously, and heating and cooling loads. And it also helps scale down the amount of equipment that you might need in your mechanical systems. And you can do all that while still hopefully meeting your ventilation and energy standards and needs. And it can also help to improve your indoor air quality. So these are really cool and efficient and effective systems, key systems to really learn a little bit more about. And hopefully you will do that in your own time or ask your mechanical professionals and engineers. So we're going to dive deep into filtration, filters themselves as a technology, as well as approaches to the wider concept of what filtration means for air quality. Now, currently, when we bring fresh air in, it's typically filtered once at the air handling unit or the primary air handling unit, depending on how your building is designed and how your mechanical system is configured. So this is just a single pass filtration. And then that air is delivered throughout the building. Now, there is an increasing focus, and again, with some of the different field studies and research and case studies that we've been particularly interested in, there's an increasing focus on recirculation units. So these are units with filtration, and there's a decentralization of air treatment as a solution. So less focus on a central air handling unit and a central BMS system, building management system, and instead an increased focus in how to develop local BMSs to provide more accurate control on a space-by-space level. So by reacting to indoor air quality issues that are detected by a smaller or more localized BMS, operators can specifically address indoor air quality issues in real time. And this yields a more immediate response that is informed by what's needed when it's needed. So this is sort of omitting that blanket approach of heating and cooling, and therefore the potential of needlessly running an HVAC system in order to meet generalized assumptions and calculations, and instead using really acutely designed and isolated systems that can pinpoint when and where and how the mechanical system needs to react and adjust accordingly. And one of the things that's worth pointing out, I'm going to come back to this slide in a second, but just to kind of bring all this to the forefront, we found that even if you have filtration, a lot of filtration on your main air handling units, say you filter at 90% at the air handling unit level, meaning that the filtration is supposed to be removing 90% of particulate, let's say. Theoretically, the indoor levels should be at about 10, if that's the simple calculation. However, contrary to what the calculations are promising, the levels that we found in the case studies were hovering around 40. And why? Why is that? Well, it's because of the pollution that's generated by the occupants from walking on carpeted areas, using air fresheners, cleaning products, as well as office equipment like copy machines, and infiltration that's coming from the building itself, like elevator shafts. So again, talking about this idea of understanding what filtration you need on a case-by-case basis, if you don't understand that, and if you're not looking at your overall building in these smaller sort of pinpointed areas, you could be missing the target of where you need to have better filtration. So the other point to make is that building owners and developers really are excited about this because it means that they can spend less money and energy for their overall systems, for the core and shell, and they can spend a little bit more time focusing on, again, where energy is needed when it's needed. So in keeping with this theme, the way that we have found to be most successful when trying to filter air after a number of different field studies, a host of different field studies of lots of iterations that are focusing on this topic, the overwhelming conclusion regarding single pass filtration is that it really belongs in the central air handling unit, that primary unit, in a system that's properly designed to accommodate it. But for commercial interiors, it's not as successful. So you can see on the left here, this is typically what's happening in the space on a tenant by tenant space level. Namely, the filters are installed behind a diffuser, which is a really awful idea because the mechanical system wasn't designed for that. And you're only able to get a very meek amount of filtered air through this medium. And the little that you gain from that is not significant enough for the overall con, which is that it's blocking way too much airflow. And it's causing the building to run and run and run in order to try to squeeze air through all of these filters that you've put at the diffuser level. So this is really not a recommended solution. And I'm going to go more into that in just a moment. But let's talk about these recirculation filtration units that we're seeing. Just a really quick analogy here. You'll see on the left, there's a portable unit, and on the right, an example of a ceiling mount or an induct unit that would go up above into the ACT. So recirculation units that are filtered, we're currently seeing these two different types and two different applications. The first is depicted there on the left. It's a portable device. Most of us are probably familiar with this in residential circumstances. It's a small unit, it has a fan in it, and you just plug it into the wall. And you use this to purify the air in small spaces. And they're really originally meant for particulate removal, or at least that's when they became most popular. Now these units can remove a number of different pollutants, including secondhand smoke and VOCs. They're using activated carbon filters to do that. You can get a HEPA grade filter, and they can filter out bacteria. And there are also some specially designed filters for the removal of CO2. And additionally depicted, the portable unit on the left, depicted on the right is the ceiling mounted induct unit. These are more industrial-sized versions of these portable units, and they're meant for in-ceiling or mechanically installed into what would be a part of the ductwork. Now, in the past, these were only used in really high-risk environments like hospitals or clean rooms, but we're now seeing them be applied in much more broad scopes and much more widely given applications. So one of the examples I give is I think in casinos when smoking is allowed, you'll see systems like this to help keep the air quality at a safe level. I'm not sure what casinos allow smoking anymore, but if you looked at their ducting system and their filtration system, it probably is likely to be something similar to this. So there's a lot of studies that we've done about the effectiveness of the portable units versus a ceiling unit. And this is a case study that was looking at their effectiveness over just the space of 1 hour. And it's between a portable unit and a ceiling unit. You can see here the ceiling unit is depicted in red and the portable is depicted with the blue line here. So both rooms start at around 100. And again, this is looking at PM levels. So starting at about 100, the portable unit reduced the levels of particulate matter to what is considered by the World Health Organization's healthy limit. And it did that in the course of 45 minutes. Now, for a classroom, again, this is trying to record what happens in a classroom. 45 minutes is a very long time. If it's an hour-long class and the kids get up and go to recess or go to lunch or go to their next class, then that's really almost the entire time of them being occupants in the room that it took for the filter to actually be effective. So not the greatest results. And in comparison, if you look at the ceiling unit, which is here depicted as fixed installation, so this one, fixed installation, it's actually showing that it reached World Health Organization limits in just 12 minutes. So this is much better for a classroom setting. And the other important thing about this to note is that you can turn the unit off once it's reached those levels, and you can let it stay idle. In other words, save energy because you're not running the unit anymore. So therefore, you're getting a double impact. You're getting sort of a double a twofer by having clean air and then also turning the system off to save a little bit of energy. So the lesson is that in-sealing gets you to healthier levels faster, and you can, again, turn the unit off to get better energy performance. So pretty provocative and gives you some extra pause to think about the benefits of one versus the other. And this is another important piece, and probably the one that's most obvious to people who have used a portable unit before. The reason why in-sealing is becoming more and more popular is because the portable units are only effective at cleaning the air that's around them. And I know a lot of people who lived in China and worked in very polluted places, and they would tether their portable units to them, basically, or have them on rollers so that they could move them from space to space as needed. Now, I don't know about most of you, but that's not a realistic option that can be used for longevity. So unless you actually strap this portable unit to your body or somehow put it in a backpack and carry it around with you all the time, it's really not going to be all that effective, and certainly not in larger commercial installations or large tenant fit outs, or certainly for an entire building. So not realistic. So for the purposes of having better filtration that's more consistent, an in-sealing unit makes a lot more sense. It's a lot more effective based on the simple fact that it's a continuation of the ducting system. So it's more likely to have a uniform distribution of airflow and further less obstruction owing to things like furniture that could impede or block the airflow. So definitely a smarter application versus something that you would just plug into the wall. And then the next step in the effectiveness of this concept is the overall approach and the tactic of tying them to an automated system. So using monitors to help determine when the filtration units need to be utilized. And if you do that, similar to this study that was conducted by Pure Living, if you use an on-demand automation system that can be programmed and it can turn the system on or off depending on certain scenarios, the note here is that the automation was based on a pre-programming setting that turned the machine off when the outdoor PM levels dropped below 75. So you're able to tell it to be smart and efficient and let the monitors sort of drive the system. And in that way, it can pinpoint when to be active versus non-active. So this is really intelligent filtering and operations controls. So we see emerging from this a hybrid system, these sort of mini BMS systems that I talked about that work in tandem with the larger central BMS. And it's proving to be really, really accurate and very effective. And then as a sidebar, we're seeing entirely new opportunities for specialists and building professionals who know how to design and install and commission these systems. So again, just to further enunciate this point, the importance of automation and the wisdom of pairing monitors with it is to avoid the scenario that you see here. Again, another study that was sort of pointing out the problems and the risks associated with human error. So Blue is an on-demand automated system design demonstrating high efficiency by only running the system during working hours. And it is consistently addressing pollution levels. So if you look at this, the blue line is the automated system where it's actually communicating with the building. It's on when it needs to be, and it's turning off when it's not because of what is programmed in as working hours. Now the red is the example of the manual system that they were monitoring, and its erratic plot lines really are demonstrating what happens when a system is manually turned off, or in this instance, it could have been incorrect speed setting. It's not only wasting energy, but it's also not providing a consistent amount of filtered air. So you're probably going to get occupant complaints. And further, it's revealing how the system for some reason, wasn't turned off after working hours. And that's even a bigger waste of energy, because in this case, it looks like it ran all night long after everybody had already left the space. So it's common to see this in manual operations, unfortunately, but it's really interfering with the indoor air quality effectiveness, and it's just a huge waste of energy. So a big plus if you can automate your system and have it tie in with your monitoring. And then this is another really juicy piece of information. There's a lot to look at on this slide, but this study with Peer Living is trying to delve into and discover what is the most affordable and effective combination of technology. So if we're trying to get an average reduction, what can we use in combination to actually get there? And again, this is just pointing to that decreasing focus on solo systems that are trying to filter all by themselves, or centralized air handling units that are trying to handle all the filtration needs all alone. And it's really a focus on a combination of recirculation filtration systems in addition to bringing in outside air, or whatever combination that might be most suitable for your situation. But certainly pointing to the fact that if you use a system entirely on its own, it's not nearly going to prove as effective as trying to couple up these new technologies. And again, as you might recall, I told you that I was going to come back to this slide, which is looking at the effects of human activity. And this graphic is showing and demonstrating what happens when we can track what happens inside a building and look at the difference between the pollutants of the outdoor air. And this slide is great because it's actually quite typical of most cities in North America, where your outdoor PM levels are really never too terrible. I mean, we've obviously have some instances of fires lately. You might be so unfortunate as to live in an area that is a non-attainment, or perhaps you are in an area where there's industry that are affecting PM levels. But for the most part, this is very indicative of what happens in the US. We have outdoor PM levels that are not terrible. They might climb up to 70 or 80, but they're not terrible. The problem is, though, is you can see by this highlighted point here where it's showing inverted outdoor air PM levels. The blue line, which is our indoor air, is higher than what is the red line representing the outdoor air. And the problem with that is that an inverted PM reading is actually showing that due to human behaviors or whatever instances are happening inside the building are proving that your PM levels are actually exceeding even those that are occurring outside. And so when we go back to this idea of human activity generating pollutants and increasing the need for filtration, it's proven through the monitoring that this is obviously a problem, even in places where PM outdoors can be quite at levels that are quite low. So I want to talk for a second about a case study that was implementing one of these recirculation filtration systems in their space. And this is a client that was extraordinarily private. We had to sign NDAs with them, and the entire case study was kept in absolute confidence. Until this day, that was recorded back in 2013. And again, this was in Shanghai. This was called the Air Apocalypse of 2013. Since then, there have been many, but this was one of the first. And this is when the outdoor levels of particulate rose to nearly 600. You can see this by the red line that's at the top of this graph. These were numbers that many had never seen before, and the average over that course of time was 472 micrograms. It's just a staggering amount. It's 12 times over what the US EPA deems to be healthy limits, which is the green bar that you see across the bottom. So again, this is one of the first air apocalypses to hit Shanghai. But if you look, the office, which is this sort of thin blue line that's being recorded here, this particular office was able to maintain levels that averaged about 34 micrograms. And when the client saw this, we got a phone call from them and they said, "Can you make this public? Can you make it public right now?" And this was really an amazing feat because not only were the numbers just worth bragging about, because to have a protection factor of that by 93% was absolutely unheard of, but they wanted their staff to know that their office was among the safest places to be in Shanghai at that time. So you can imagine very few staff complaints. In fact, they recorded no staff complaints during the highest PM levels that were recorded in 10 years. And it went very far to not only build employee confidence in their space and with their company, but this employer is able to use this information for marketing and PR purposes, as well as attract and retain some of the best talent for his staff. So I'm going to talk a moment really briefly about the concept of using air scrubbers. And this is, again, just another iteration of, I guess, what you could call filters and filtration. So in keeping with that same theme, air scrubbers, as they're fondly called, are systems that have filters that are specific to targeted pollutants. And they either dissolve the pollutants or they trap them, depending upon what the pollutant is and the technology that's employed. Everyone has slightly different technologies. But those are, whatever is trapped is subsequently released or exhausted, and it needs to be exhausted on a regular basis. Now, ideally, you exhaust to the outdoors if it's part of the HVAC system, or it's through a dedicated pipe or some venting. And this is just one example of what these systems look like, courtesy of Envirid. And again, you can address a number of different pollutants with these systems. And you can actually apply them in either the mechanical rooms or they can be smaller units that are ceiling mounted. But what's important to talk about is that, again, we have some really interesting innovations that are coming on board to actually deal with this idea of how do we reduce and how do we filter, and can we do it with systems that can actually be retrofitted, or can we actually use them in new construction and new design? And in this case, they have units that are accommodating to both scenarios. And it's worth mentioning that, again, once you reduce your CO2, it allows for a subsequent reduction of outdoor air intake and hence reduced energy use. So all good things. And then it's important for us to think about some other, organic or inherent means to consider when we're trying to solve filtration issues. For example, I know this is not a very glamorous slide, but we should certainly look at and hopefully benefit from more studies that compare how air reacts to filtration depending on how it's delivered to a space. So, for example, is underfloor more effective versus ceiling delivery methods? So isolating out not just the filtration medium that's being utilized, but how it's being delivered to the space, and isolating and decoupling those two studies would be really interesting, as would linking that to concepts of separation systems. So ideas where we're interested in seeing studies and experiments with approaches that look at how do we dilute versus separate, or separate versus dilute. And the whole dilution system is, I think, what a lot of us have been leaning on thus far. But can we get some studies that talk about separation systems? So again, it's a different approach to filtration, and one that's hopefully going to be shared as people get more results from experiments with this. And there's really a wealth of strategies that are yet to be explored. And I'm hoping that everybody out there is going to be as excited about the possibilities as we are. Looking, for example, studies that are focusing on zoning. So retail spaces or hospitality spaces, for instance, where there's a lot of people that are walking in and out all the time. These spaces are incredibly difficult to manage. It's making it really hard to control the interior environment when you've got openings that need to be actually penetrated all the time by people needing to come in or people needing to exit. You can't get rid of that fact. So these are really prime areas of experimentation and research that we should implement some different methodologies and in particularly challenging scenarios to learn something from it. So I'm going to jump across really, really quickly to ionization because it is, I suppose, a means of filtration, depending on how you think of the definition, but it's more a concept of a solution to indoor air quality. And certainly filtration because naturally air is ionized. And this happens through positive and negatively charged ions as a part of just natural occurrences. So air ions occur as a result of high energy sources being introduced or present in the atmosphere, and they decompose gas molecules into atoms. So examples of this would be near waterfalls or during a lightning storm. Ocean surf, even sunlight and UV can create this ionization effect. But you can do it mechanically as well. And again, I'm using air quotes around mechanically because bipolar ionization systems, they create these charged air molecules by either adding or removing an electron using one of three different types of ionization systems, which is either photon ionization, nuclear ionization, or electronic ionization. And one of the benefits of bipolar ionization is that the ions, conceptually and in most cases that we've seen with the systems that we've been looking at, they seek out the oppositely charged particles. And the idea is they combine or they attach to one another. And when they do that to things such as VOCs or odor-causing bacteria, they can impede their ability to travel and, I guess, again, ostensibly trapping them, for lack of a better word, and or converting them into other compounds like water, and hence helping to remove them from the air. Now, we're not ionization experts, and there are some really important characteristics of bipolar ionization that should be discussed with any supplier that you're working with. And one is the output concentration levels of the ions, which is to say the ratio between positive ions and negative ions. And the second is the concentration of ozone that's being produced in the air ionization process. Air ionization is always accompanied by generation of ozone. So you really need to ensure that you understand the technology and that it's appropriate for your application, and that you understand from the manufacturer how the byproduct of ozone is being dealt with in their system. So again, we're not experts on bipolar ionization by any means, but as with every technology, we take the position of measured caution and curious optimism. We've read some really compelling case studies in real world applications where clients have been extraordinarily satisfied with the results. So we advise, as always, do your homework and due diligence and be sure to ask companies to provide you with thorough and transparent information. So I'm going to jump next to living machines and plant technology. Now, this is a pretty exciting territory because what it can do is hopefully reverse what we have been sort of looking at, this idea of plugging in an air filter and hoping that it cleans your space and cleans your room. I've already talked about some of the failings of a plug and play portable unit like this. Again, unless you actually have it on a backpack or you intend to tether it to you, it's only going to clean the air that's around you. Not very efficient. So this traditional means, as we've come to know it as portable units, is a little lackluster. And the bigger picture and the problem of what this is doing means we need to understand where the energy is coming from. From what source is your energy that is actually fueling your device? So coal is obviously one of the most heavily used energy sources. It's a major problem. And ironically, like the electric car, again, I don't want to pick on the electric car because I think they're absolutely fantastic. But only in areas where they're using renewable energy does it really make a lot of practical sense. Because again, ironically, the more you use energy to clean your environment, the more we're actually polluting that. And until most societies can actually move away from burning fossil fuels for energy, we have a problem on our hands. And the portable units are no exception to that. So with the units, and these are numbers that are showing that for every amount of VOC and PM you try to remove by plugging in an air filter, well, the draw that it's having to pull by, again, using fossil fuels, in this case coal, you're contributing all of these other pollutants to the environment, which you're trying to filter in the first place. So it's a race to the bottom with this kind of approach. You're introducing heavy metals and NOx and SOx and all sorts of things to the environment for the merely tiny amount in comparison of clean air that you're trying to produce. So this is, again, not a solution that we need to be leaning on. We need to start looking at different innovations. And one of which is the living plants and the plant technology that has been around for years. So going back to a study that was done by NASA, hopefully a lot of you have heard about this, Dr. Wolverton in the 1960s. This was a result of when Apollo 13 had a race back to Earth because they were going to suffocate due to massive quantities of CO2. So Dr. Wolverton was put to the task by NASA to sort of look at, well, how do we actually live up in space for extended periods of time in such a harsh environment where we're inevitably going to be running out of breathable oxygen? And he came up with, again, what I hope a lot of you have heard of, is that for having air that's breathable and cleanable enough for human consumption, you need 8 plants per person. So this 8 plants for every person can be applied to spaces, and it can be done for an interior space in a residence. It can be done in an office. So using this technology, we've also since learned, again, thanks to NASA, is that we can have very sophisticated versions of this work. We've now learned that it's actually the root system of plants that are the real workhorses behind the plants, not the leaves, not the foliage. And they're the ones that are actually really doing the heavy lift of purifying the air. The roots have beneficial microbes that feed on captured air pollutants. It's incredible what nature is able to do. So if you then accelerate the movement of air past the root system, you can get an increase in the effectiveness that's over 100 times that of just a plant alone. And some studies have actually shown that it's 200 times the elimination versus plants that are grown passively in soil. So our little plant that went from just 1 plant for every 8 person, well, for 8 persons, well, now you can actually reduce that and you can have fewer plants in a space as long as you have a more effective and efficient delivery system for what the root systems are able to purify. Now, it's also very cool to note that, again, by asking what would nature do, we're solving multiple problems at once. You can take 2 bad things, such as VOCs and CO2, and you can convert them into 3 good things, just because plants do what plants do. So they create sugar and biomass and oxygen. They don't create nasty byproducts. And not to mention, of course, all the other really great benefits that come along with living walls and plants, the biophilic elements that cannot be forgotten. Foliage and all of the beauty that plants bring, health and happiness-wise, I think have to be mentioned. So again, we're looking at increased oxygen, and we're looking at decreased energy costs because you're having to do less filtration in your space, and you're having to do it with 0 energy if you allow your plants to do that work for you. And at the same time, you're getting a decrease in PM. Now, I'm going to talk about PM in just 1 second. So if you remember, a couple of slides ago, I was showing a project. This is the slide again. It's a partnership that was done, a field study that was done by Lend-Lease China. And their director was a real fan of NASA's work with respect to plants and their effects on indoor air quality pollution reduction. And he decided that he wanted to implement the recommendations from Dr. Wolverton's research in his China office. So he put greenery everywhere. He exceeded the 8 plants per person ratio by far. There was a large green wall in the lobby near windows for light and for ease of maintenance. Really beautiful sort of interior landscaping. And they used the recommended species as well, a very purposeful and pointed application. And again, looking at how they used the plants, it was very clever because it served to keep clutter to a minimum in the office, which helped to keep it cleaner. So again, trying to keep dust and particulate from gathering on objects that are typically strewn around in an office, the plants served a really great purpose. They kept the surfaces full of greenery instead of full of clutter. And the results from this office were staggering. The space was able to achieve CO2 levels that had not been seen in about 150 years. So global CO2 at the time was 405, and the office was reporting CO2 at 280. So this office, in implementing the plants, attained levels that were pre-global warming levels. So again, numbers that we haven't seen in about 150 years. And walking through this office is, I have to tell you, it's a visceral experience. The greenness of it actually hits you when you enter it. So yes, the numbers are amazing, staggering, in fact, but the feeling that you experience by walking into the space, the office and the implementation of the plants, that concept, it just sells itself. So again, it's a beautiful space and contributes to the health and the happiness and the mentality of the people who occupy the space through the biophilic elements of plants as well. Now, if you remember way back in the target pollutant modules, I was mentioning Gensler's firm-wide research project 2016 that was done in collaboration with Pure Living China and with Clear. And we were looking at the efficacy of plants in the reduction of or regulation of CO2 levels. So this study, again, just to reiterate, the same 3 participants were spending 2 hours working in each of the study environments. One was called the gray room, where there was no green wall, and the other was the green room, where, as the name would suggest, they have installed a green wall. And they were really trying to study the effects of the plants in the reduction of CO2. So hence the 2-hour controlled meeting room study to measure the CO2 reduction. And again, the occupants are not interacting. They're not talking to one another. They're just sitting there. And if you remember, I talked about the reduction of CO2 levels that were expressed. It's not overly surprising data that was collected. I don't think anybody really fell off their chair when they saw that in the green room, the CO2 levels were actually lower than that in the gray room. No big shock there. But what is really interesting, when we looked more closely at the data that was collected, there were some really amazing discoveries that were indeed surprising. So there's a lot on this slide. I know it's a lot to read, but just give it a moment and I'll go through it and show you a detail of this space here that's actually in orange. So this is the particulate, the PM graph. There's the green room, of course, is the green line. The gray room is represented by the gray line. The air conditioning, which is the mechanical system, is this sort of like hat-shaped off and on datum. And then the standard, which is the hopefully the standard of PM, the recommended level that you would like to attain, is expressed by this dashed line here. So when we actually zoom in and we look at the data, these sort of shapes of the air conditioning unit, this is showing that the HVAC system is turning off and turning on again. So on the graph, you can see when the mechanical system is off, the PM levels rise. And that's again because it's exacerbated by the fact that if there's high levels of pollutants outdoors and your HVAC system is turned off, the building is no longer filtering. So no big surprise there. When you zoom in on this, okay, so again, this is our mechanical system turning off and on again. And we've got our gray room expressed by the gray bars that are measuring our PM levels. And we have the green lines that are expressing the measurements in the green room. And then the dashed line is showing where we would like to attain and maintain our PM levels as expressed by Healthy Limits, World Health Organization, EPA. So if we're actually looking at what happens when the HVAC system is turning on, it's able to keep the PM levels at a reasonably low level. It's doing what it's supposed to do in this case, which is filter the outside air, the recirculated air, in addition. When the system is off, the PM levels rise. If you look closely at the green room, you can see a notable, consistently low level of particulate matter, which can only be deduced that the plants are actually helping to keep the PM levels down. And this was merely a passive green wall. It's not an active one. There was no air being pushed through the root system. It's just a green wall that was inactive in the conference space. So imagine the potential that a living machine would have and the great innovations that are yet to be discovered, because plants up until now have never been known or thought to eliminate particulate matter. So again, really surprising findings for a study that set out to actually look at CO2 levels, but because we monitored the space and because we had a good design that could actually look at the results in a way that we could actually do some deductions, we actually discovered something that probably is not widely known. And again, that plants can be effective and prove to be effective and in the reduction of particulate matter. So as I mentioned in this slide earlier, that they have a positive effect in that they can increase oxygen and clean air in a space, but do so by the means that are just inherent. So you've got a reduction in energy because you're not having to pull from energy loads in order for plants to actually do what they do. And at the same time, you're getting that extra bonus of reduction in particulate matter. So really interesting and great ideas and innovations. It just begs the questions of what innovations are yet to come. And we really hope that some of the solutions that were presented and that we've learned from are inspiring to you, that you as a future AP can take to your clients and to your projects and start being brave and applying new ways to solve these complex problems. So congratulations, you've now come to the end of yet another module, and I look forward to joining you in the last one where we're going to be discussing productivity and ROI.